Now, we are going to solve quadratic equations that involve rearranging in this video. You can only perform the middle term breaking in the previous video if your quadratic equation is in the following form. And that form is the unified form that we have for quadratic equations, which is ax square plus bx plus c. That means the coefficient of x square comes first, the coefficient of the term including x square comes first, the term including x comes after, and the constant coming after that, and that equates to 0. This is the standard order for the quadratic for writing of the quadratic equations. And if you want to solve your quadratic equations using the methods taught you in the previous video, you are going to have to convert your equation into this form if it's not in this form. Hence why this video is quadratic equation, and this video is named as quadratic equations involving the rearranging. If it's not in this form, then you will have to rearrange before you actually solve the question, or you may say that before you proceed with the steps of middle term breaking. Now let's look at an example. For example, we have a question before us, which is x square plus we have a question before us that is x square plus 10 minus 7x equals to 0. Now this, it is not in the form ax square plus bx plus c, because the x square, the coefficient, the term including the x is not after the term of x square. It's not in the second in order from the left. So we need to rearrange it. And how are we going to rearrange it? It's very simple. Minus 7x comes here, 10 goes over there. It now rearranges to x square minus 7x plus 10 equals 0. So after rearranging, you have x square minus 7x plus 10 equals to 0. Now you perform middle term breaking on this simplified and rearranged quadratic equation, and then you compare your working with ours in the next slide. Now attempt these questions and then compare your working with ours. Now while rearranging to come to the form ax square plus bx plus c, you need to be extremely careful that the coefficient of x square is positive. So you need to rearrange it in such a way that the coefficient of x square is positive. If the coefficient of x square is negative, then that means that you need to transfer everything on the other side so that it's a positive, that so that the coefficient of x square is positive, and then you need to start middle term breaking from that point onwards. Like for example, we have a question before us which is 15 minus x squared minus 2x equals 0. Now we see that the equation is not rearranged in the form ax squared plus c, and also of the coefficient of x square is not positive. We can rearrange it to be like this, like making minus x square over here, bringing minus 2x over here, and bringing 15 over here. But that's going to give us minus x square minus 2x plus 15 equals 0. Now, most of the students might be compelled to rearrange it in this way only and go ahead with it, but this leads to tedious and chaotic working. So you should rather take the x square on the other side, and obviously when you're taking x square on the other side, you are gonna take everything on the other side, and when you're taking x square on the other side, x square is becoming positive, so you need to do that. So we're gonna take x square on the other side first. We're left with minus 2x plus 15 on this side, and we have an x square on this side. And now we need to take minus 2x and plus 15 towards x square as well. So we're gonna do that as well in the same step. So we have nothing left over here, so we have 0 left over here. On this side, x square minus 2x comes over here, becomes a positive 2x, plus 15 comes over here, becomes a negative 15. And we know that we can write this equation as this form as well. So x square plus 2x minus 15 equals 0. So now our equation is in the form ax square plus bx plus c equals 0. If we have converted it from this form to this form, so now in the next slide, uh, you pause the video to solve this question on your own. This simplified perform middle term breaking of this after rearranging. We have already rearranged for you. You perform the middle term breaking of it, and then in the next slide there is the working for it, and then you can compare your working with ours. Now, there are some quadratic equations that you may have to simplify prior to actually rearranging or prior to actually solving. An example of such a question can be like x bracket x plus 7 plus 6 equals to 0. Now, this does not look as a quadratic equation on the outset. So what we're going to do is we're going to try to expand the bracket and simplify it as much as we can. So we're going to expand this bracket. X multiplies with this first, and then x multiplies with this. X times x is an x square. X times plus 7 is a plus 7x. And then plus 6 gets copied as it is. So a typical quadratic equation we've come up with. Now you solve this equation further, pause the video, and then compare your working with ours. Now, you need to be careful with questions that do not have a constant in them. For example, question like 2x squared minus 4x equals 0. Now, the right way to solve a question like this is, like in step 1, you factorize. Now, factorize in simple meaning is you take common, as we've already learned before. So factorize means you take out the common from these two. 2x square minus 4x equals 0. What do both of them have in common? Both of them have a 2 in common. 2 being in common means that both of them can be divided by a 2. Both of them have an x in common as well. 2x square has 2 x's, 4x has 1x, so both of them have at least 1 x as common. So we're going to take 2 and x out as common, then that means we're going to take 2x out as common. When we have taken out 2x from 2x square, that means when we've divided 2x square from 2x, we're only left with an x. And when we've taken 2x away from minus 4x, when we've divided minus 4x by 2x, that means we're left with a minus 2. And then we close the bracket, we copy equals to 0 as it is. Step 2 for this kind of a question is that you solve each separately with a 0. Solve each separately means, like for example, we have 2x bracket x minus 4 equals to 0. We're going to solve 2x equals to 0 separately. We're going to solve x minus 4 equals to 0 separately. We take 2 on the other side, it's 0 upon 2 and this becomes a 0. So x is equals to 0 is one value. We have x minus 4, we take 4 on the other side, it becomes a positive 4. We have two values, x equals to 0, x is equals to 4. Now why do we need to take common, and why do we need to avoid any other way? We're also going to discuss that over here. We're going to discuss a wrong way that we are very compelled to use at the outset, but it is you are going to understand why should you avoid performing the method. So the wrong way, let's discuss the wrong way for this one. So for example, if you have, we're going to solve the same question using the wrong way, 2x square minus 4x equals 0. Now you might be compelled to take 4x on the other side and becomes a 4x. And then you might be compelled to cancel 2 then, like 2, 1 over here, 2 2s, and you'll be left with x squared equals to 2x. And then you might be compelled to take x on this side, x squared upon x equals 2, and you might be compelled to cancel 1x with one of the x's, and you might be like, I have an answer, x is equals to 2. Okay, one mistake, this was a minus 2 over here, so our answer is going to be a 2 over here. So that was a silly mistake, so we've corrected that. Anyways, so we were getting x equals to 2 over here, all right, whereas previously the right method gave us two values. It gave us x is equals to 0 and x is equals to 2, whereas solving this is only giving us one value of x, which is x is equals to 2. So if you're doing it the wrong way, that means you're compromising one value, one root of x, and that obviously should not be done, because the examiner is going to be expecting you to give two answers, and if you give one, you're going to be losing marks on that equation. So this way you'll use one of the roots, and this way should be avoided.